I am with the ACIL staff. I would like to welcome you to today's webinar, Cost-Effective and Efficient Data Handling and Reporting for Environmental Laboratories. Before we begin, I'd like to review a few points of protocol so that you'll get the most out of your webinar experience. Remember, you are listening to the webinar via a conference service. If you are disconnected, read the steps that were given to you by the meeting registration email. If you have any questions throughout the presentation, please type them located on the right-hand side of your screen under the Q&A tab. The presenter will respond to questions as they become available. If your question is not answered, of course, the presentation, it will be answered during the Q&A section at the end of the webinar. The presenter contact information is available in the last slide of the presentation. Please note that today's program is being recorded. Now it is my pleasure to introduce our presenter, Mark Tischler. Mark is a software engineering manager focused on mass spectrometry at Agilent Technologies. Mark's academic credentials include BS Biochemistry, Cornell, MS Analytical Chemistry, University of Maryland, MS Computer Science, Virginia Tech, and MS Engineering Management, Santa Clara University. Job experience ranges from EPA, USDA, FDA as a chemist, software engineer at HP, enterprise integration consultant during the dot-com boom, software manager at GE, and software manager for the LCQQQ, GCQQQ, and GCQTOF Mass Hunter acquisition and quantitation software introductions in the last 10 years. Ladies and gentlemen, please welcome Mark Tischler.
Thanks, Tony. Appreciate the introduction. Pleased to have the opportunity to talk to this audience about an important topic entitled Cost-Effective High-Throughput Pipeline for Environmental Labs. So the topic is explained here a little bit in more detail. And I'm going to focus on the environmental aspects of it and the quantitative aspects. So if you believe that analysis is the key bottleneck, then this discussion of migrating from legacy software is pertinent. So migration. I like to think of migration in this thermodynamic sense of activation energy. So I will identify the compelling reasons for you to move from one spot in legacy software over that barrier to another. And as you can see, there's multiple dimensions, and we'll cover these. The operating system compatibility, security constraints, deployment, LIMS integration, and the training and validation that's involved. Let me break that down into three different categories for you. Compatibility, security, and then vendor support. So a little bit of history here, set that context. For those of you who were around in the what I'll call pre-PC revolution, remember the integrators that were there. I remember working on the PDP-11 back in graduate school, and when I first joined HP, I worked for a while on the HP 3000 mini computer with environmental solutions in the early days of HP. If we look at what happened in the late 90s, you'll see the PC revolution. So here is the early days of the 5890 and 5971. You can see that that was released in Windows 3.0. And it was about that time that the PC revolution happened. Here is the 6890 and the 5973 GCMS that was released on Windows XP. At that time, networking was changed from the HPIB card to the network card. And you can see that things have moved along at a rapid pace. So that's one of the themes that I like to establish here, is that the PC took over. And if you went to ASMS at that time, you would see that the vast majority of software applications run on Windows PC. And that's simply because of the price-performance argument. By the way, that's still true today. If we look at the changes in the Windows operating system, this can trigger a lot of memories if you've been around through these changes. But the operating system has changed quite rapidly, especially if you compare it to the rate of change of analytical methodologies So I will focus on XP as an example. So you see here that Microsoft declared that XP is no longer supported. This is the issue with supporting newer instruments and devices, and the fact that if you look over here, you can see that from 2014 that XP was still alive. So this rate of change affects us in the analytical industry. The same is true here of Microsoft servers, and herein lies the problem. A legacy application is not necessarily supported well on the older servers. So this presents a problem for IT. They do not want to support legacy applications on older servers. So another related technology is the displays. So I'd like to share some of my thinking here. Today, cell phones and tablets are coming on strong. But my view is that when we talk about advanced applications like quantitative analysis that involve analysts making decisions and interaction, it's difficult to beat the dual monitor display. And that tablet does give you the touch, but you can't really match the fact that you have the mouse control with the fine aspects of it, and you need the real estate to show that information. If you look at this chart, which shows what is happening today during the day, you can see that people do use their cell phones and tablets, but when it comes to the working hours, the PC still dominates for the reasons that I gave you. And I think that will continue, and I'll show you in some demos why you need that real estate and why you need the power. All right, so let's go back to XP. So XP created a situation for Microsoft. After that, they focused on security. But XP, especially Internet Explorer 6, had a chock full of security holes. And that caused a lot of problems. So here lies another part of the problem. If you hang back in technology, you end up exposed to a level of security problems. All right, so the last is vendor support. So I'll bring in a personal story here. I was responsible for validating Throughput's target software, which was sold as a value added on top of HPUX ChemStation. And let me say that I was proud to work on Target, which was an excellent environmental package back in the late 80s and early 90s. So a little bit of history. Going back to the PC revolution, the PC price performance that kicked in the late 80s forced an obsolescence of HPUX here in the late 90s. What happened then is Target moved from the X Windows display to PC displays after that, and then later Target changed hands, and then we're talking today in 2015 about Target. There's a number of shops that are still using Target as a case example. Many of them are running Agilent equipment. That was often the basis. Certainly a distinction to be made here is that Target was a multi-vendor solution and to focus on Agilent instrumentation. All right, so that's a little background of where we are. Let me talk about the migration process. So the migration process is something that you need a plan. This is back to project management where I've spent most of my career. You need to evaluate the risks. You need to look at running a pilot program and then migrate in phased steps. And I'll walk you through a series of features and tools with some quick demos focusing on the quantitative aspects, and that will be the central focus for the rest of the talk to show you how to look at where you are with the legacy software and then the expectation that the vendor is going to provide you the vast majority of the solution, and then the migration task of hooking up is where I'll end up with this talk. All right. So the migration task. If you're on a legacy platform, I'm going to talk about MassHunter EnviroQuant, and I'm going to talk about the integration tools and the migration roadmap that would lead you in that direction. I like to show this slide because it shows the investment that has been made in MassHunter over the last 10 years. The program was initiated back in 2004 as a software answer for the MassSpec platform. And as mentioned, I was involved with the LC triple, GC triple, and the GC QTOF instrument introductions. And you can see the features have been added over this period of time. In the recent years, there's been a focus on the drug quant workflow, and then this shipping release and the next release, strong focus on the EnviroQuant workflows, which I'll talk about in some detail here. All right, so I'm going to go through a fairly extensive set of features and show you that list that's helpful in the environmental labs. I'll start with what's always asked for first, which is getting past tune evaluation. So Quant offers you a tune evaluation tool which can be triggered from acquisition. And this tool automates decision-making, which is typically done by the analyst, where they would manipulate the spectra to get it to match the criteria that are necessary in terms of the ion ratios, et cetera. And this allows you to try those solutions out in an automated way so you can get the tune pass, or you can, of course, do it manually and pick one of them. But this is a tool, and there's a whole series of tools that I'll go through here, which are going to help you do the day-to-day activities that the analyst needs to get through. Another part of tune evaluation is the chromatography aspects of it. If you look at DDT breakdown, there's criteria here to know that your instrument, the injection port temperature, et cetera, is working. There are other compounds that you want to check their degradation. So this setup automates that, which could have been done on an Excel spreadsheet or by hand, but this sets it up for you to make sure that your instrument is functioning properly before you run your samples. This is all ending up in a PDF report with this decisions documented, how the tune passed, and this all happens with one click. All right, let me move next to continuing calibration, which is the heart of GCMS or GC environmental workflows, especially here in the US of A. And it's the idea of reusing the initial calibration based on acceptance criteria. Now I'm going to have to apologize. I'm going to use a fair amount of environmental lingo here, so if you are not an environmental person, I might end up losing some people. So I'm going to jump forward into some terminology. So environmental with continuing cal, we offer a series of calibration tools which will help you manipulate your initial calibration curve to pass by manipulating levels. We also, similar to Target, by the way, Target called these exceptions, we call them outliers, but we give you features which allow you to evaluate the continuing cal curve to make sure that it's accepted and passed. And you can see that we have almost 50 outliers now, a variety that you can turn on and do pre-canned calculations. In terms of the continuing cal, it would be evaluating the initial cal. All right, let me turn my attention to manual integration, which is often seen as the bottleneck in analysis. I'll show you several sets of tools here. The first, a toolbar which allows you to speed up actions which are common. And I know from target users, one of the favorites is the snap to baseline. So this, I will show you a quick demo here. And in this demo, you see compounds at a glance, which is a tiled view of the results. And it enables compound by compound review, often more efficient than sample by sample review. And you'll see the manual integration that's happening here. I'm drawing that baseline, and then I'll use the snap to baseline. But the compounds at a glance presentation allows you to do manual integration or zero peaking. That saves a lot of precision keystrokes and allows you to get through the time-consuming parts of manual integration. All right, I've got a pretty good speed. I'm going to keep it up. Another aspect which often comes up is, can I document the before and the after? So an analyst makes a decision to manually integrate. I would like to see that on the report. This is especially useful if QA needs to review those results before they go out. You can look at that decision on the report because you can see the display of the original integration that came from the integrator and compare that to the decision that the analyst made. Helps with visualization. Another very useful tool that could fit into your SOPs is the need to document the reasons. So manual integration is such an important part that a number of SOPs want the analyst to document from a series of reasons which can be customized. And you can put this toolbar addition on. This is an example of extending the product with an add-in. So the add-in puts this toolbar here, and when the analyst manual integrates, they can add in that reason, which will be recorded. This speeds up a lot of activities if you're doing manual integration. All right, so here is a quick demo that shows you how that works with the toolbar. This is the GC flavor, so it shows you only the aspects from a chromatography point of view. So this will show you again the snap to baseline and then the use of recording the decision with that toolbar addition there. In this case, there's a code BA that's recorded. All right, last, somebody might say, well, listen, I'd really like the integrator to take care of integration for me. So we have a number of integrator approaches. We put a lot of effort into a parameterless integrator. So let me show you a couple advantages of those. First, the resolution of the shoulder peak is shown here, and then the smarts of the integrator, which uses a statistical approach to figure out what's noise and what's signal, and then is able to follow the local baseline and do a good job of drawing peaks which are on a sloping baseline. So this is the parameterless integrator. We do support all of the existing parameter integrators if you need that fine granularity control. An integrator that you might not have run across, the spectral summation integrator. This comes into play with the next workflow I'll talk about, TPH. This allows you to sum the area, and you can use establishing the baseline, which is the tricky part of this. You can establish that by fixed retention times. So potentially you could use the beginning of the run before the elution profile shows up as the base setting the baseline for your summation of, I'll say, a boiling point range. All right, let me jump into several specific workflows that we've put into this environmental package. First, TPH. So those of you who are in the industry, it's likely that your environmental lab is doing TPH. What we've done is put in the mechanics of what we call compound math, and compound math has the smarts. You'll see that in a couple different ways here, but it has the smarts to take two associated peaks and to manipulate them. In this case, we're going to subtract the contributions of the ISTD or surrogate from the determination of the TPH, and that's necessary in this protocol. So let me give you a quick demo. So this shows you a very simple setup where I've got the TPH compound and I've got a surrogate, and you'll see that the method editor here, I've set up compound math to do the TPH subtraction, and I'm using the spectral summation integrator. So you'll see this spectral summation integrator in use here, giving you the choices that I just discussed. Gives you a view of the method editor and setting this up. So I will use an absolute baseline from the beginning of the chromatogram to establish that, that baseline point. So here I go over to what we call batch at a glance. You can see the results. You can see the curve that's created by adjusting the area, subtracting the ISTD or surrogate contribution to get the adjusted responses. So that's fully integrated with the calibration curve. All right, another important workflow is matrix spike recovery, often needed to satisfy the limits that the matrix, whether it's soil or water or however you've got it, passes through your sample prep. You need quality metrics. So we do provide those calculations for the surrogate, for the matrix spike, for the LCS type, with several matrix limits supported so that you can adjust that. And this calculation will be made automatically and check against those limits to give you a recovery. So let me show you that in, again, compounds at a glance. So compounds at a glance lets you overlay these, the sample and the matrix spike of that sample so that you can see that the retention times line up. That's very important to establish the confirming evidence that you've got the right compound, and then shows you highlighted if that compound has gone outside the limits of that matrix spike recovery. All right, I'm going to keep going here because these tools are the crux of speeding up and getting to a high throughput, high productivity game plan. So I'll cover minimum detectable limit, which is a task that is required to establish, let's say, by instrument, the detection limits, sometimes related to system suitability. So we have a tool that will take multiple replicate injections and do the statistical calculations. I'll show that to you in a demo here. So this tool takes those replicate injections and uses the t-test statistics to determine the MDL limits, LOQ and LOD limits, as well as some other okay, I've got a note there coming. Mm-hmm. So I think I'm going to keep going because I've got a lot of material and I'll come back to that.
Okay, very good.
These statistics are used to determine the MDL limits, and you can see I can set those directly in the method using this tool and then go forward adjusting my method with those calculations. Again, you can do this in a spreadsheet, but this is integrated into the application. All right, AeroChlor PCBs. Again, you might or might not be doing this, but if you are, there's a workflow typically done in GC based, and I'd like to take you through that. We support that workflow with, again, compound math. So the trick with aerocore PCBs is that you need to find peaks in that particular aerocore that do not have interferences and represent the concentration of that particular aerocore. So you need to pick 5 peaks typically that are aggregated together to make that representative concentration. So we have put together a tool which does that for you. You can see from this diagram. Again, we'll give you a demo here, how that works. Here we are again in the method editor, and we're going to make an association of a set of compounds that belong together in these different aerocores. Aerocore 1016 and aerocore 1260. So you'll see here the peaks that are grouped together in the compound math and the calibration curve that results from that. You'll see the aggregated sum. So you're able to filter on one aerocore and move through that aerocore and see the results. And let me mention, in the upcoming release, we'll have a GC chromatogram window which allows the analyst to pick those peaks so that they can establish which peaks are appropriate for each aerocore determination. There's more to be said there, but I will keep the broad picture here and move ahead with the unified method. So if you're working with samples, multiple instruments, and I'll mention in a moment multiple sites potentially, it's important to collect the method together, especially from the analysis point of view. And the unified method, what I mean by that is the parts of the method are broken into component parts, the report, and I'll show you the library in a second. And those component parts are stored together in what is traditionally called the .m. And you can, the beauty of this is that you can mix and match parts of the method together to form another derived method. That's what is labeled the unified method. So the most recent addition to the unified method is the library method. So the library method stores the libraries that will be searched. You can put your pesticide library in front of the NIST library. You could attach retention time or retention index criteria. That certainly helps you reduce the false positives. And okay, so the unified method will come into play in a moment. Let me take that thought and move into an aspect that's often required by environmental, which is to show you the total ion chromatogram, to integrate that and show you the library result of any peak that is not a target. We provide you that in a menu item where you can generate that report and document non-targets using the total ion chromatogram and then invoking library search with the library method that I just discussed. So let me give you a quick demo of that. Here we are in batch at a glance, and I'm going to just trigger that report, and this will go off and start up an application which will do the TIC integration, then invoke the library searching of in this case, multiple libraries, including the NIST library. And if we had a blank, it would subtract hits from the blank and do target matching at the end. And here you see the result in library search report, which has documented any peak which is non-target and gives you the library score and then the area percent of that. This is often necessary to document this as part of the quantitation product as an extension to target analysis. All right, I'm doing okay on time, but I think this is the most complicated part that I was going to discuss, and I think I'm going to skip it so I have some time to get to the questions at the end. But we do have the capability of providing you a tool that helps the analyst look at non-target interferences. So I'll just mention this and I'll skip over the demo. This tool allows you to look in detail at potentially a target which has shown some issues with, let's say, the library matching of the spectra, and you can study the interferences. If you're in a heavy matrix background, you often get colluting compounds. You might want to consider using a different target or qualifier ion, and this tool helps the analyst make that decision if necessary. So I will skip over that demo for sake of time. And I'd like to discuss what I'll call confidence. I can use the word confirmation. Some people believe that can only happen in church, but confirmation of a result, a measure of confidence, is important. If you're going to report results, it comes down to false negatives and false positives, and you certainly don't want to err any more than you need to. So a positive may have somebody taking an action on it. You want to make sure that you've got solid results there. So how do you get there? Well, one approach that does work well with GCMSDs is the SimScan. So SimScan, which I believe with Target you need to run 2 different injections. With one injection you can do both the sim and you don't really sacrifice much on the sensitivity, but what you get out of that is a library match score which helps you in your confidence that you do have that compound and it's not really, you're not being tricked by another interfering compound. So this combination of quantitation with what I'll call confirmation is a workflow that we support in a number of different ways. This is the normal way that you're expected SimScan. And I'll show you another way which is new. So this is some of the innovation that the product brings. There is a technique that is called deconvolution. You might think of it as a sophisticated way of cleaning up the spectra because it takes out ions which don't form the same model peak shape together. So if you look at what, here we have a lot of 44 in the background. It's a background ion, but after deconvolution you can see how the cleaned up spectra improves the score and gives you a much better representation than you would have if you just averaged the spectra. This deconvolution does it automatically and provides you that spectral matching and builds the confidence that you've got the right result. All right, so here's a very quick demo of target deconvolution with its smart, what I'll call auto background correction, and you can see there a very nice spectral match. The scores do improve, and I do believe that will help you reduce your false positives. All right, a theme that I would like to emphasize, I already mentioned it in a couple different ways with the outliers, is review by exception. So the analyst has too many results if they have to review all of them. So the idea here is let's focus on the set that's important. So with the outliers, I'm able to focus. So I'll take sample amount as a threshold of reporting limit, and I'll say that my lab wants to review any result that's above the reporting limit. So I'll show you that here in batch at a glance, and in this case you can see that particular sample 5 has triggered a lot of the over the reporting limit. And this will show you how to do that in compounds at a glance. So compounds at a glance is often where people go. And you can see there's a lot of tiles there to look at. But the tiles that have been highlighted are the ones that are over the reporting limit. And you can see here in the method, the reporting limit is turned on. And so I'm just going to filter down to the results that are over the reporting limit. And now I've got a situation where I'm looking at those, and I can go in and either manually integrate or zero peak them out and end up quickly taking a group of those and operating on them. That can save a lot of time. We have, as I mentioned, almost 50 outliers, and you can set that review by exception up with qualifier ratios, matrix spike recoveries, a whole different set that works for how your lab operates. All right, rounding the corner. Let me spend a little time with sublist. Now, sublist was a technique that was adopted by many target customers to get them to high productivity. Sublist, what I mean by sublist is the ability to filter down to the client, seeing only his set of samples and only the compounds that they paid for using the limits that they wanted. That ability can let you run the same samples on the same instrument with the same acquisition method, and then the analyst spends his time reviewing the compounds that the client has paid for. So in Mass Hunter, we've got that. We can use the sample group to dissect this Venn diagram to the particular client and then associate the compound group with the set of compounds that that client is paying for, and then the analyst can zero in on that. So here is a demo that shows you how to use the compound group and the sample group to zero in on one particular customer's needs. So this sets it up with customer 1, and you can see the filtering happen there. It sets the compound group up with customer 1. And now you can go through and do your review of the results. And reporting works in a very similar context. This will show you generating the report. The front end of it, which is that you can choose the samples and choose the compounds that are associated with that client by selecting that group again, the customer 1 group, including the compounds. And now your report only shows you that filtered set. So that matches a workflow that was often used by large environmental labs that are pushing out samples for specific clients. All right. Let me get to reporting, and then I'll take some questions. Reporting, we have a package that involves PDF reporting. PDF reporting does a great job of showing you the report. I show you the audit trail report here and mention that not that we're necessarily in a compliant environment. We do offer an integration into a compliant environment, but the audit trail is turned on by a number of customers who want to record the actions of the analyst in case they need to go back. So here's an example which shows you that manual integration was recorded in the audit trail. But going back to reporting, the benefit of PDF reporting technology that we employ here is that it's fast. So speed makes a difference in high productivity labs. And it produces a PDF report which is easily navigated by, let's say, your QA department or even your customer who wants to drill into those results. So here is a result in the drug quant flavor, but it gives you the same idea of generating a report with the report method. And this report has some nice features. So one of the features that this will show you is the bookmark. So if you have a large number of samples and a large number of compounds, how can you navigate this report, which can consist of hundreds of pages, and you want an index into it. So here's the bookmarks, and the bookmarks allow you to jump into a particular sample or compound and to review those results quickly. And I will mention in passing here, we do have the ability to customize these reports, all the way from putting your logo in to adding and deleting a column or even a custom calculation. Oh, this goes a little bit further and shows you some of the tools that come with Adobe, where you could, let's say the QA person could put their signature in there, and it is recorded in Adobe's actions, and the document does understand that it was approved. So that could be useful in keeping track of who looked at it and sent it through your pipeline. Okay. Let's broaden out here in the tail end of this talk and talk about LIMS exporting. LIMS exporting is often done with a CSV file and the file drop, but I would like to talk a little bit about a little more advanced technique. I'll call it direct SQL insert. And this shows you that with the flexible tools that we have, I don't really have the time to cover those tools in a lot of detail here, but we use, okay, I'm going to get to that one in a second. I'll come back to those. Let me finish here. Good question. I see that we're going to use Python, which is the most popular language now, and all the folks coming out of engineering school are being taught Python. Python code, things today are easier, and this is part of this technology revolution that I'm talking about. So let's say that you do have your LIMS database and you have an SQL database, very common. I'm going to show you that you could connect, insert, and commit those as a transaction into the database. This is something that you would want to do if you had your IT department, and it's often the case that the results need to be pushed into the LIMS. Let's say not all of the detailed results of the quality metrics, but the LIMS serves as the client repository for the clients to see their results. So this demo will show you a very simple case here, which takes you into a little bit of the technology, but this shows you how we go out through reporting, through, again, a reporting method. But this reporting method will run the ability to connect to the database through Python. I call Python the new CP macro for those of you who have been involved in GCMSD ChemStation. And this will connect to a LIMS. I used SQL Server, but you could be using Oracle or IBM DB2, whatever. And here's the server, and this just shows you that that information did get inserted into tables that have been created here. This is a dummy example. You, of course, have your own LIMS, you have your own database, you have your own database schema, you have your own tables, etc. But it is possible with this recipe to integrate. Of course, the CSV has been supported for a long time, but this shows you how you could, what I'll call SQL Direct Connect. All right. I'd like to mention something that I saw with Envision, with Target, which is the ability to do cross-batch reporting. Often in a large lab, you want to keep track of how your instruments are doing, let's say, or how batches are proceeding. One of the things that affects labs is you order a new set of ISTD standards and you propagate those through the lab. So the quality of your lab has, you have to monitor that quality and ensure your customers are going to get solid results. So this tool, which is an Excel-based tool, and it's based on the pivot table and the pivot chart, which is the most powerful part of Excel, allows you to produce charts that can compare across batches, and you can monitor that your ISTDs, in this case, they're looking very good across all of these batches. But you can monitor a number of different aspects of the calibration curve or your target responses and produce charts like this, useful in larger labs. Here's a quick demo that shows you how to launch that for one batch, and that it generates charts to show you the consistency across one batch. So this will generate a set of fixed tables. This shows you the ISTDs. As I mentioned, you can see in sample 1 down here, it looks that we forgot to add the ISTD. That's something that does happen, and you need to keep an eye on it. So this chart that's integrated right in gives you that ability to look at a couple of charts. Here's the compound responses across the calibrations and the QCs and the samples, as I pointed out. All right. Last, I'm going to wind down and broaden out with networks. And I don't think I need to convince anybody the power of getting onto the network, the power of centralizing, and the cost-effective nature of that in a high-throughput lab. The client-server architecture that I'm describing here is having the PC, and I mentioned the power of the dual monitor and having the power of the PC, and I'm going to show you a configuration. You may already be doing this. This is a recipe that applies to a, let's call it a non-compliant environment using Microsoft security for the file systems, and how that can be arranged at a very low cost, efficient manner for you to share. So this gives you a picture of that. We set this up, wrote up an application note, and you can see some of the advantages are immediately obvious for centralization, the archiving and the backup, centralized printing. You can use Microsoft's index search to find things once you have the data in one place, and you have the file security and the virus checking that comes with Microsoft. So the game here is that acquisition runs and then deposits the data onto the server. This is very similar to the way the HPUX ChemStation worked, with the data being deposited on the server. So we do have in the application note the instructions for what's called a post-run action that will push the data up to the server in an organized way. So the analysts really operate on the data on the server, so your master copy of the data remains there. So one large advantage of this is that if you had the unified method, which I mentioned before, and you had consistency across sites in terms of the way analysts approach problems, potentially you could, with your unified method, if one site got backed up with samples in a project and you had to finish it on time, you could assign either instruments or analysts from another site to work on that data if it's stored in the central location and get your project finished on time. I call this load balancing, and this is often the case in multi-site situations. You want to get to the point. Now, the key here is the unified approach to having a methodology that would be shared across sites. All right, so with that thought, I will wrap up and say that the cost-effective high-throughput pipeline that I've talked about with the central network integration has acquisition on the front end, a topology of client-server with a dedicated PC client sharing data and methods with a central network. I talked about the network attached storage. There is a compliant solution for mass spec with the ECM. That would be a better fit if you're in a more regulated environment like pharma. And the tools that surround that, I focused on EnviroQuant. We have the qualitative analysis. I showed you some of the unknowns, QRS, and the reporting. And then out to your limbs, the workflow is something that we participate with you to get to the solution, which is not just the analysis application, but the entire system workflow. All right, so I'm going to open it up now for questions. I think I've got something in here in the chat room.
Yes, you do, Mark. The first one is from Greg.
Okay. Is it true, PDF digital signatures or PDF type image? So that's Adobe technology. So Adobe uses the word digital signature very loosely, so I have adopted that. They consider the bitmap image that I showed as a digital signature. So no, that is not what I'll call a certified digital signature where you set that up. There's a lot of overhead in doing that. That's a much more sophisticated approach than what I showed you. I showed you a low-cost, cost-efficient manner where somebody would just denote the that they had finished doing the report. It's really just simply a bitmap.
Okay, Mark, and we have another question from Greg earlier.
Okay. Is there a compatibility matrix for Mass Hunter with existing Agilent GCMS estimated 30% would be on XP or Windows? Okay, so the solution that I showed you with the NAS solution, where the data is copied over the network, with XP and network card, you could implement that, because really what needs to happen is the data needs to be copied. Once you're finished with acquisition that way, that would work on an XP system, so, or Windows 2000 system, because that's really all that's needed. The acquisition subsystem is running as basically as a standalone system. And once the data is up in the shared location, the analyst would work from there. So Mass Hunter does support the formats from the GCMSD, of course, and some others like the Varian formats. Again, Agilent doesn't, let me make that caveat clear, Agilent does not support the wide range of multi-vendor formats that Target Throughput did. I want to make sure I've said that. Does that answer your question, Greg? Okay, I hope so.
I hope so too, yeah. Are there any additional questions? If you have a question, just type it into the question box. Any more? I think so.
Yeah, we had a question on the line.
Yes. Is there going to be continued support for GCMSD ChemStation EnviroQuant, or is Agilent eventually migrating everything to Mass Hunter?
Well, the GCMSD ChemStation has a very large installed base, so there's no intent to, on the immediate horizon, to obsolete the GCMSD ChemStation. There's a lot of folks who are embedded in that. It is a solid solution. So I focused this talk on pointing to Target Throughput customers, but obviously there are some that are looking at GCMSD ChemStation and the potential of moving forward. So I hope that answers your question. I'm not sure I gave you exact dates, but they both have their purposes. If you've my opinion on that, to throw it in, if you've got what you need and it's working for you, and you can absorb these things that I talked about, the compatibility issues, the vendor support issues, the security issues, if you've got what you need, then stick. Well, my argument here was that there's compelling reason to move forward to get to a high productivity environment that's offered with Mass Hunter.
Thank you very much.
Any additional questions? You want to type them in your Q&A box? Okay, I don't see any more. Well, again, thank you, Mark, for your presentation, and again, thank you all for your participation today, and we look forward to you joining us for our next webinar on May 15th, 2015, 1 p.m. Eastern Time, entitled Assessing Customer Satisfaction. Thank you all again. Day.
Thanks for your attention.